Enhancing cost efficiency for Tesla and promoting widespread adoption of our electric vehicles remains top prioritized, as emphasized by Elon Musk in a message. Our current battery pack can travel about 300,000 to 500,000 miles. But the upcoming battery pack, expected to begin production next year, will be specially designed to run 1 million miles. Now, imagine owning a car that can travel 1 million or even 1.5 million miles. This means your car could last a lifetime, and a battery pack capable of running millions of miles is no longer a distant dream. It'll soon hit the market under the Tesla brand. How could this type of battery revolutionize the automotive industry? How is the process of turning the dream of a multi-million-mile battery into a reality unfolding? There have been numerous rumors about a million-mile battery for Tesla vehicles, and the company often accompanies such rumors, confirming the existence of this battery type. In a Bloomberg interview, Contemporary Amperex Technology Limited, or CATL, Chairman Zheng Yukun, stated that the company is ready to manufacture the battery. According to him, this new battery type will have a lifespan of 16 years and enough energy to cover 1.5 million miles, up from the previously reported 1.24 million miles. A million-mile battery doesn't mean you can drive millions of miles on a single charge. It means the battery can sustainably power the vehicle for 1 million miles or more before losing its ability to hold a charge. Regular charging every few hundred miles remains necessary to keep the vehicle operational. Today's batteries face limitations on the number of charge cycles they can endure. Most car batteries are rated for about 1,000 full charge cycles, with a manufacturer warranty typically covering around 8 years and 150,000 miles. A million-mile battery could handle over 4,000 full charge cycles. So, what sets this battery apart from others? The million-mile battery represents a significant advancement in battery technology, with the goal of increasing lifespan and performance compared to traditional lithium-ion batteries. While the basic structure remains unchanged, key improvements could lie in the use of new battery chemicals like lithium nickel manganese cobalt oxide, or NMC for short, offering higher energy density and durability. The energy density of the battery is increased by up to 30%, while the cathode's lifespan is significantly improved by up to 5 times. Wow! Additionally, the cathode and anode structure has been improved to increase operational efficiency and reduce the risk of damage. The new cathode and anode structures help increase operational efficiency and significantly reduce the risk of damage by 10% and 50% respectively. Furthermore, the battery management system, or BMS, has been enhanced to monitor and control battery operation optimally, thereby extending battery lifespan and optimizing the performance of electric vehicles. These improvements promise new prospects in the electric vehicle industry and contribute to reducing emissions and environmental pollution. As for CATL's readiness, the company has stated that they will manufacture the batteries as soon as they receive orders for million-mile battery packs. Although much of this news surrounds Tesla, the company has yet to make a separate announcement. At the very least, we know that Tesla has previously worked with researchers on this technology and will soon be applying it in their vehicles. The battery supplier for Tesla has achieved a significant breakthrough in battery technology that could power electric vehicle sales for many years to come. It's known that LFP is cheaper because its energy density is about 160 watt-hours per kilogram compared to lithium-ion NMC at around 240 to 290 watt-hours per kilogram. LFP faces another challenge when sodium-ion batteries, also produced by CATL, are being manufactured. Sodium or salt has more lithium, so we're not really sure about the future of LFP batteries. If they have similar energy densities, we don't know why we would choose the more expensive option. As far as we know, the recent production of the Tesla Y SR-RWD model uses LFP. It's like a trial model to see how the market reacts to the LFP vehicles. With Amprius' silicon anode Li-ion battery, QuantumScape solid-state Li-metal battery, and CATL's condensing battery all have a power of about 500 watt-hours per kilogram. LFP and sodium-ion can only target the lower-priced car market. That's why all Chinese vehicles are using the new LFP battery, and they're being tested now. Today's batteries face limitations on the number of charge cycles they can endure. Currently, many battery types are rated for about 1,000 full charge cycles. The manufacturer's warranty for car batteries is increasing from about 8 to 15 years and 150,000 miles. This shows the conservatism of car batteries in general, with a longer warranty period indicating a longer lifespan. A million-mile battery could handle over 4,000 full charge cycles. So, the Chinese company supplying Tesla has developed a power supply with a lifespan of up to 16 years and 2 million kilometers or 1.2 miles. And it's possible to reuse it on another vehicle. The new type of battery can run for millions of miles based on low chemical amounts and does not contain cobalt, among other products developed jointly with CATL's cutting-edge Ampex technology. This type of battery is certainly more expensive than CATL's conventional batteries. Although it's more than 10% more expensive, its lifespan compensates for that. Even the battery could be considered an asset for car buyers if it can be transferred to another vehicle and can run for 1 million miles. CATL is predicting rapid growth in the electric vehicle industry and is investing in further research and development in battery technology. How does the compatibility of this battery align with Tesla's current electric vehicle models? The technology used in Tesla's electric vehicles is undergoing continuous development. Two types of batteries are considered the focus of battery technology: M3P batteries and lithium-ion batteries. M3P batteries, also known as lithium phosphate, are mixed with manganese to increase energy density, meeting the demands of long-range electric vehicle models like the Model 2. On the other hand, the lithium-ion phosphate battery pack from CATL is capable of fast charging up to 500 kilowatts, even performing effectively in harsh weather conditions. This is the result of advancements in LFP, lithium iron phosphate battery technology, one of the first types of batteries that can do this and has better energy density. Tesla's been using this type of battery in the Model 3 and Model Y, and it seems they'll focus more on using them in commercial applications such as buses and trucks. Developing batteries with better capabilities and lower costs will help address many transportation and environmental issues, replacing diesel vehicles and reducing environmental pollution. Will the Model 2 Redwood be equipped with this type of battery? Integrating a million-mile battery may require changes in the design and systems of the Model 2, leading to high development costs. Tesla needs to carefully consider the feasibility and economic efficiency of applying new battery technology to the Model 2. Equipping the Model 2 with a million-mile battery could increase the selling price by an additional $5,000 to $10,000, exceeding Tesla's initial price for this model of $25,000. This could potentially make the Model 2 lose its price competitiveness against the electric vehicle companies like GM or Nissan, especially competitors from China like BYD. Model 2 customers are typically more concerned about price and practicality than range, as most daily travel needs are under 200 to 250 miles, which conventional battery ranges already satisfy. Integrating a million-mile battery into the Model 2 may require significant changes in the vehicle's design and systems, leading to a high development cost. North American surveys show that 60% of electric vehicle buyers only need a range of 250 miles or less for daily use. Therefore, equipping the Model 2 with a million-mile, equivalent to 1.6 million kilometer battery may be overkill for many customers. The higher cost of a million-mile battery could lead to potential Model 2 customers choosing other cheaper electric vehicle options. In Tesla's strategy, they may be focusing on applying million-mile battery technology to premium models first to attract those high-paying customers. Once this battery develops further and the costs go down, Tesla may consider not applying it to the Model 2. Because CATL's a game-changing battery that the Model 2 is going to use with fast charging capabilities and cold weather performance up to 350 kilowatts. Tesla's new battery for the Model 2 will be supplied by CATL and will use their advanced technology, promising significant improvements in the electric driving experience. It's expected that the market share of Tesla vehicles in the U.S. will be increasing from 30 to 40%, with Tesla being one of the leading manufacturers in this field. This prediction's been made by Tony Seba, with a focus on advancing low-cost battery improvements that's expected to open up a large market for EVs. CATL's LFP technology will be used for the Tesla Model 2, ushering in a new era in electric vehicle battery technology. These special LFP batteries not only make electric vehicles flatter and more appealing compared to gas models, but also provide fast charging capabilities and lower production costs. This will help the Tesla Model 2 achieve an astonishing range, a significant step forward in driving the development of electric vehicles. In Europe, CATL's LFP battery has been recognized with the 2024 AutoBest TechnoBest Award, honoring innovation and breakthroughs in battery technology. Producing LFP batteries at Giga Nevada for Tesla's Model 2 marks an important milestone, as well as an effective collaboration between the two leading manufacturers of the field. A notable feature of LFP batteries is the ability to charge nearly full in just 15 minutes. This opens up a great potential for using EVs in daily life, as users can charge quickly and conveniently in not a lot of time. Although LFP batteries typically don't perform well in cold weather, CATL's new batteries have demonstrated improved performance in those harsh winter conditions. It's expected that the Tesla Model 2 will have a charging speed of up to 350 kilowatts and use long-lasting battery packs. These new LFP battery packs have higher energy density from 10 to 15%, providing a wider operating range and better efficiency with lower production costs. This will help Tesla reduce production costs and make the Model 2 more appealing to consumers. What do you think about Tesla Model 2 using this new game-changing battery instead of LFP batteries from CATL? Will this help Tesla achieve their goal of 10 million vehicles each year? What impact could the future availability of 1 million-mile batteries have on the market for other types of batteries? The new technology will change the ownership experience of owning a car, whether it's a Tesla or a vehicle produced by competitors like General Motors. Companies are always developing while also researching new battery technologies. Especially the long lifespan of batteries will soon be introduced to the market, meaning that batteries can retain enough value to be resold when owners change their cars, possibly for use in storing solar energy in households. And the long lifespan of the next-gen batteries may allow them to be used in ride-sharing businesses that require vehicles to withstand heavy loads when used nearly continuously. If Tesla's million-mile battery, which eliminates cobalt, seems poised to dominate the electric vehicle industry, meanwhile, lithium iron phosphates have never been proven effective in the limited space conditions of electric cars, initially designed for the electricity grid storage market due to its energy density characteristics. But its chemical properties are suitable for fast charging and cost saving because it doesn't depend on cobalt, which Tesla and CATL are still developing to eliminate, not completely, but significantly. Eliminating cobalt is the key to extinguishing the dreams of other battery types. Cobalt's the most expensive element in lithium-ion batteries. It accounts for 20% of the battery production cost. The price of cobalt's decreased recently, but it's still much higher than other raw materials. The price of cobalt today in April 2024 actually fluctuates around $30,000 a ton, much higher than the price of lithium around $15,000 a ton and nickel at around $20,000 a ton. Eliminating cobalt from batteries could help reduce the cost of batteries to below $100 a kilowatt hour. This is the price level needed for electric vehicles to compete with internal combustion engine vehicles. Cobalt, also the focus of a new race by miners to extract minerals from the ocean floor, has long been a commodity challenge for major tech companies, not just Tesla, but also Apple, that require cobalt for their phone batteries. It's also become a pretty politically sensitive issue, with some of the largest cobalt suppliers coming from the Democratic Republic, where allegations of child labor deaths in mining have recently sparked international crises involving Apple, Tesla, Google, and other tech companies. New chemistry could push EV battery prices down to $60 to $80 per kilowatt hour. Bloomberg NAF predicts prices will surpass $100 in 2023 or 2024 and by $60 by 2030. Tesla's important new supplier is Chinese battery manufacturer CATL, also partnering up with Volkswagen. CATL's chairman previously stated that they're ready to produce high lifespan batteries, but they still haven't completely eliminated cobalt. At GM, new batteries are cutting cobalt content to around 4.5% in batteries, down from 18% with more manganese and nickel, along with some aluminum making a significant difference. Battery competition and development are also vibrant as the number of companies involved in researching and developing salt and solid-state batteries has doubled in the last 3 years, attracting over $10 billion in investment in 2023. Major electric vehicle manufacturers like Tesla, Toyota, BMW, Volkswagen, they've all committed to using salt or solid-state batteries for their new models in the future, and that shows great potential of these two technologies. In the evolutionary journey of electric vehicles, the battle of battery technologies is getting increasingly intense. Potential contenders such as sodium-ion and solid-state batteries are emerging to compete with Tesla's batteries, which currently dominate the market with a 70% global market share in electric vehicle batteries. Sodium-ion batteries have attracted attention for their potential to replace lithium-ion with sodium, promising a 30% cost reduction and 10% increase in efficiency. These batteries are also highly regarded for their safety and durability, especially at high temps. However, challenges regarding weight, which is more than 20% heavier, and size, which is over 15% larger compared to lithium-ion batteries, still needs to be addressed. Solid-state batteries impress with their ability to double the energy density of up to 400 watt-hours per kilogram compared to traditional lithium-ion batteries at 265 watt-hours a kg. This opens up potential for smaller EVs to travel twice the distance without needing frequent recharging. However, the higher production cost, 5 times higher, and the need for further technological refinement still pose significant challenges. Tesla's batteries, with breakthroughs in performance and reliability, continue leading the race. Integration of efficient materials and modern production processes has enabled Tesla's batteries to achieve high energy density, be 10% lighter, and have a lifespan twice as long, 3,500 charging cycles, compared to lithium-ion batteries. Moreover, the use of graphite in the battery structure enhances performance and minimizes the risk of explosions. Natron Energy aims to reduce electric vehicle battery production costs by half through the development of sodium-ion batteries. Solid Power, in partnership with BMW, are working on solid-state batteries expected to be integrated in their EVs by 2025. Meanwhile, Tesla is conducting research on lithium iron phosphate LFP batteries, which offers increased longevity and safety compared to traditional lithium-ion batteries. These efforts prioritize delivering high-value, long-lasting electric vehicle batteries while minimizing production costs. Such advancements not only enhance electric vehicle performance and range, but also contribute to the creation of environmentally friendly and energy-efficient products. With substantial investments in research and development, Tesla and other manufacturers are driving innovation in the electric vehicle battery industry. We hope you'll experience the utmost relaxation after watching this video. If you do, please press the like button and join the community by subscribing to our channel. Hit the notification bell to stay tuned for any fantastic videos coming your way. Your feedback and time are highly appreciated. Unbelievable battery tech. The emergence of this battery is completely capable of making Tesla soon abandon its 4680 battery production. Chinese battery manufacturer CATL has revealed the LFP Gen 3 battery, the first battery to achieve a range of over 600 miles with 4C superfast charging. What's even crazier is that Tesla's made a big move with this battery, even bringing it into production at Giga Nevada this year. Tesla EVs only need to be charged for 10 minutes to get nearly 400 miles of operation, which Elon Musk has been waiting on all these years. So why will this be the end of 4680 battery cells? As far as we know, no battery manufacturer in the world has ever dared to confidently announce that an electric vehicle can go for an entire month without needing to recharge. While many might perceive this as an exaggeration, CATL has indeed unveiled a groundbreaking battery type with their latest innovations. At Auto China 2024, CATL introduced the world's first LFP battery type capable of achieving a range of over 620 miles along with its super-fast 4C charging capability. According to some internal sources at CATL, during the revelation, Tesla has continued discussions with CATL to manufacture this type of battery at Giga Nevada by acquiring the necessary equipment and production machinery for these battery cells. Tesla is expected to obtain large quantities of these LFP battery cells by the end of the year. One major reason we believe this to be true is that the timeline perfectly aligns with Tesla's initiation of the Juniper project for its best-selling Model Y. It's conceivable that the SUV will undergo significant refreshes in terms of both exterior design, interior features, and functionality. The purpose of this refresh is likely due to the Model Y gradually losing its appeal after nearly 5 years on the market without a major overhaul, especially in the face of stiff competition. If this LFP battery indeed finds its way into the new SUV, it's highly probable that a new sales record will be set once again. Returning to the details of this latest battery technology, we like to refer to it as the LFP Gen 3 battery, as CATL has indeed produced 3 different types of LFP batteries: a series of conventional LFP, Shenxing battery, and Shenxing Plus. We're surprised by the rapid advancement in fast charging capabilities by the Chinese manufacturer. Just 8 months after the launch of the fast-charging Shenxing battery in August 2023, CATL introduced the advanced LFP battery technology of Shenxing Plus, marking a new era of fast charging across the industry. In fact, both the LFP Gen 3 battery and Shenxing Plus battery have been improved by over 40% compared to their Gen 2 counterparts. This is precisely evident when considering the range they can provide for electric vehicles. The manufacturer has announced a range of 1,000 kilometers, equivalent to 621 miles for these new battery cells, whereas their predecessors only allowed for a range of 700 kilometers or 434 miles on a full charge. Regarding the enhanced optimization in the LFP Gen 3 battery, CATL states that achieving 621 miles for the super battery is thanks to continuous technological breakthroughs. So, what potential does Shenxing Plus have to replace the 4680 battery? First, let's find out what CATL did to upgrade this battery technology. Specifically, the cathode of LFP Gen 3 is made with granular gradation technology, which places every nanometer particle in the optimal position to achieve ultra-high compact density. The proprietary 3D honeycomb-shaped material is added to the anode, boosting the energy density while effectively controlling the volume expansion during charge and discharge cycles. The single-piece casing, which is an industry first, optimizes the internal space utilization, allowing the LFP Gen 3 battery cells to reach unprecedented energy density level. At this system level, the LFP Gen 3 battery pack has a topological structure optimized on top of module-free CTP 3.0 technology, enhancing the packing efficiency by 7%. Through breakthroughs in material and structure, the Shenxing battery system's energy density surpasses the 200 watt-hour per kilogram threshold for the first time, hitting 205 watt-hours a kilogram, making ranges over 620 miles a reality. This time, the LFP Gen 3 battery pack exhibits an optimized structure that uses module-free CTP 3.0 technology. This design allows electric vehicles to achieve ranges in excess of 1,000 kilometers, approximately 621 miles, pushing the boundaries of what's possible in electric vehicle travel distances. Why will LFP Gen 3 batteries eliminate EV conflicts? We're not sure if this is entirely accurate, but from a personal perspective, we observe that the adoption rate of electric vehicles, including Tesla's EVs, remains relatively slow. EVs face challenges in convincing consumers because nearly all industries today are grappling with a perplexing issue. If one aims to maximize extended range, it often comes at the expense of fast charging capability for that EV. The significant contradiction is best illustrated by vehicles like the Lucid Air, boasting an impressive driving range of 520 miles, but lacking in fast charging capability. This means drivers have to prioritize between long journeys with frequent charging stops or opting for faster charging with a risk of range anxiety. Even with Tesla electric vehicles, which have an average range of slightly over 300 miles and an average charging speed of 25 to 30 minutes, it's not slow but still not good enough to elevate the customer experience to a higher level, and Tesla sometimes still needs to compromise. However, the LFP Gen 3 battery has demonstrated that this trade-off is not truly necessary. This breakthrough technology breaks through traditional boundaries between driving range and charging speed, providing the best combination of two top criteria for an EV: outstanding driving range and super fast charging speed, achieving nearly 400 miles in just 10 minutes of charging. It's surprising that the world's leading battery manufacturer consistently maintains cutting-edge battery production technology. Despite upgrades, CATL continues to retain the advantage of the old generation, focusing instead on eliminating the weaknesses and limitations of Gen 2. With the LFP3 Gen 3 battery, it still maintains an impressive charging capability of 4C, but it advances significantly beyond the LFP Gen 2. Specifically, it can add up to 600 kilometers, approximately 370 miles, in just 10 minutes of charging. This is a substantial improvement over the previous year's battery cells Gen 2, which could only recover 400 kilometers, about 249 miles, in the same time frame. To illustrate this super-fast charging speed, typically a battery charges at 1C would take an hour to fully charge, so charging at 4C is significantly faster than that. This speed is so fast that many people have been skeptical because fast charging creates a larger current, leading to increased battery temperature. Prolonged high temperatures can weaken the battery structure, accelerate aging, and reduce battery lifespan. However, CATL has meticulously accounted for this scenario. To manage the heat generated during these high-speed charging sessions, CATL has expanded the overcurrent area and increased the capacity of the contact points within the battery system. This enables rapid heat dissipation, ensuring that the battery remains safe and stable even when subjected to strong currents during 4C charging. This is not only a significant improvement for safety, but also a potential game-changer for the entire battery lifespan of the EV industry. If the Juniper project for Model Y indeed utilizes these battery technologies, the charging time holds immense promise. Currently, for Tesla Model Y, the quickest owner's choice is the Tesla Supercharger network at 250 kilowatts, taking 15 minutes to cover a range of 258 miles. However, if you're charging at home, it could take up to 4.6 days depending on the charger type, charging options, and battery capacity. In the case of the new Model Y integrating LFP Gen 3 battery, just 10 minutes will get us at least a 300-mile range, a significant improvement in both charging time and additional range. So, how does LFP Gen 3 energy density gradually catch up with the 4680 battery? The remarkable progress in improving battery generations within just 8 months has made the LFP Gen 3 battery extremely promising as a replacement for the 4680 cells. While it may still be somewhat immature compared to the 4680, which has only been out for a few months, nobody can predict the future, especially considering the speed of CATL's product launches, a manufacturer known for its relentless pursuit and agility in providing advanced solutions to the market. In addition to its astonishing 4C charging capability, CATL's intensified efforts to enhance the energy density of its LFP battery cells. Achieving a level of 205 watt-hours per kilogram, they've surpassed a significant milestone by exceeding the threshold of 200 watt-hours per kilogram. This indicates that CATL has paid special attention to improving energy density, a traditional weakness of LFP cells. It cannot be denied that the energy density of LFP is lower compared to lithium-ion cells of the same size, resulting in shorter range for electric vehicles or shorter device usage time. To achieve the same capacity, LFP batteries need to be larger and heavier. However, improving the energy density by CATL is a significant step to mitigate this disparity and enhance the competitiveness of LFP batteries in the market. In a major effort to make its LFP Gen 3 battery more widely accessible, CATL's implemented an improvement to boost energy density to an impressive level. This enhancement was achieved through a 7% increase in packing efficiency and deployment of more complex chemical processes. Typically, LFP battery packs have an energy density range from 90 to 160 watt-hours per kilogram, so CATL's achievement represents a significant advancement in battery technology. With a current energy density reaching 205 watt-hours a kg, CATL's new battery still cannot compare to modern 4680 cells in terms of energy storage capacity. However, it's still progressing and requires time to reach maturity. Compared to Tesla's 4680 cells, which boast an energy density of 265 watt-hours a kg, although still lower than the industry's projected 330 watt-hours a kg by about 20%, they still lead in providing the largest capacity among battery technologies. However, despite the energy density not yet catching up, when it comes to cost, LFP particularly holds an advantage with a lower cost, somewhere below $100 a kilowatt-hour, quite affordable. Meanwhile, the 4680 cells have been rumored to potentially cost over $150 per kilowatt-hour, a reason why the price of the Cybertruck has increased significantly compared to its original price. Tesla is indeed trying to reduce the cost of the 4680 battery, but achieving this ambitious cost reduction goal poses significant challenges. The initial efforts by Tesla with a 4680 battery only managed to reduce manufacturing costs by 20%, mainly by leveraging the larger design of the battery and its integration into the vehicle structure. The more challenging part is mastering the dry electrode coating manufacturing method, which remains a hurdle. However, Tesla now indicates that they expect their 4680 battery to be cheaper than those from suppliers by the end of the year. According to the latest reports in early April, Tesla's 4680 production has reached over 1,000 battery packs a week, representing an increase of about 18 to 20%, or around 7 gigawatt-hours per year compared to fourth quarter of last year. Tesla's VP, Maravi, also pointed out that the current 4680 line at Tesla is closely tied to the Cybertruck assembly line. The 620-mile range of the LFP Gen 3 battery opens up an incredibly reliable possibility, allowing vehicles to travel without worrying about recharging. This not only provides convenience for daily city commutes, but also opens the door to longer interstate journeys without the need to stop for charging. The fast charging capability of the new CATL battery, coupled with a reliable driving range, could be very appealing. Its widespread adoption has the potential to set new global standards for electric vehicle performance, impacting battery development in the future and consumer expectations. While the U.S. electric vehicle market ranks behind China in scale, its growth rate is not lagging. The reemergence of numerous car manufacturers building manufacturing bases here signifies dynamic development. Although the Chinese market is larger with a dense population and abundant battery supply, this is an undeniable fact. CATL is not only revolutionizing the EV battery market with its LFP Gen 3 cells, but also laying the groundwork for a comprehensive fast charging system across China. In addition to these technological advancements, CATL is also deploying the Shenxing Plus super-fast charging network to establish the largest fast charging service platform in China. Collaborating with leading industry partners like StarCharge, YKC, Shudao New Energy, CATL aims to enhance the commuting experience for owners of vehicles equipped with Shenxing super-fast charging batteries. The Shenxing Super-Fast Charging Vehicle Owners Club is set to launch, operating at over 600 service outlets across 271 provincial-level cities in 31 provinces, offering services including roadside assistance and battery maintenance. Through these initiatives, CATL is not only pushing the boundaries of technology, but also driving a comprehensive fast-charging ecosystem, integrating batteries, networks, platforms, and services to support the future of energy-efficient vehicles. In summary, Tesla's plan to adopt this type of battery is only a matter of time, considering the potential and the convenience and performance promised by the LFP Gen 3 battery. Known for its potential as a replacement for the 4680, This type of battery only needs a significant technological leap to achieve higher energy density, and the results could surpass current batteries by far. With a range of 400 miles, the LFP Gen 3 battery opens up a possibility of longer trips without frequent recharging concerns. Moreover, its 10-minute charging capability brings significant benefits to users, minimizing wait times and enhancing the convenience of electric vehicles. Another notable point is the expected significantly lower cost per kilowatt-hour of the LFP Gen 3 battery compared to other battery types, providing favorable conditions for reducing retail prices of electric vehicle models and making this technology more consumer-friendly, particularly with high safety levels that do not translate into excessive manufacturing risks. The LFP Gen 3 battery promises to be a safe and efficient choice for the future of the electric vehicle industry. CATL's LFP Gen 3 battery is a truly remarkable milestone in the electric vehicle industry, bringing breakthrough features that were previously only considered feasible in the future. However, like any other advanced technology, it also faces challenges and specific issues that need to be addressed. One of the main challenges is sustainable battery production and recycling. With a significant increase in electric vehicle adoption, the demand for high-quality batteries is also rising, raising questions about the sustainability of this crucial raw material. The extraction and processing of these materials can have a significant impact on the environment, and there's a growing demand for sourcing from reliable and environmentally friendly supply chains while minimizing environmental impact. Furthermore, the end-of-life scenario for these battery cells poses another barrier. Recycling used batteries is not only a complex and costly process, but also crucial for environmental preservation and resource extraction. Efficient recycling processes are essential for managing the life cycles of batteries sustainably and minimizing the potential ecological impacts of electric vehicles. In addition to these overarching issues, there are several specific trade-offs related to the chemistry of LFP Gen 3 batteries. As we discussed earlier regarding energy density, although LFP batteries are renowned for their safety and longevity, they typically have lower energy densities compared to other chemistries such as nickel, manganese, cobalt. This lower energy density could mean that LFP battery cells are often larger and heavier, which could affect the design and performance of electric vehicles. Manufacturers of electrical equipment and automakers really need to consider and evaluate the factors of this new battery based on their needs and suitability for their products. They also need to carefully weigh the benefits and drawbacks of LFP Gen 3 battery technology before deciding. However, Tesla seems to have wasted no time bringing it to Nevada. Perhaps this time we'll test it on electric vehicles to evaluate performance as well as durability based on cycle degradation. Of course, this requires a not-so-short time. Despite these challenges, the introduction of LFP Gen 3 battery pack marks a major step forward in the electric vehicle industry. Its advanced technology is designed to enhance the appeal of electric vehicles by addressing two key issues of concern to consumers, which are driving range and charging times. So, what do you think about this new LFP Gen 3 battery, and which Tesla EVs do you expect to get it? We appreciate your valuable contributions, and let us know what you think in the comments section. We hope you'll have the most relaxing feelings after watching this video. If you did, please hit the like button and join the Tesla Car World family by subscribing to our channel. And don't miss out on any of our awesome videos by hitting the bell icon. We value your feedback and your time. Thanks so much for watching, and we'll see you soon. Until then, stay safe and have fun.